Here we're given a block diagram and we're asked for a difference equation. And a difference equation is simply an expression of y of n in terms of x of n. So all we need to do is look at this diagram branch by branch and see what's going in and out of each of these blocks. So we start with the input, x of n. That is being multiplied by 2. So the output here would simply be 2 times x of n. That's the output at that point there. And then it's going into this block, which is just an addition block. And what's being added? Well, 2x of n is being added to whatever it is that's coming out of this t block. A t block is just a delay block. And what's being delayed? Well, the input is being delayed. And the input is simply y of n. So y of n goes in, so y of n minus 1 comes out. That's what we have there. So here we simply have the sum of these two inputs because they're both being added together. So I can simply write here I have 2x of n plus y of n minus 1. And then what happens to that signal? Well, it goes into this operator there that adds minus 1. So we have minus 1 added to that. So it's like a subtraction of 1. And then the output there feeds directly into y of n. So I can express y of n simply as twice x of n plus y of n minus 1 minus 1. So that is my difference equation. So it gives me y of n in terms of x of n and any other delayed versions of x or of y. So that's my difference equation. The next part of the question asks for a differential equation. A differential equation is not the same as a difference equation. A differential equation is for continuous time signals. So in a differential equation, what we're after is something like dy of t over dt. That's what we want to see in a differential equation. But we can't differentiate a discrete time signal, but we can approximate it. So an approximation for dy by dt is y of n minus y of n minus 1 divided by t. So this is a well-known approximation. This is what we do to approximate a first derivative. And the question is asking for a differential equation that would give us this process being that. So we'd want to rearrange this difference equation to somehow turn it into a differential equation. So we could do that by starting with the difference equation, y equals 2x of n plus y of n minus 1 minus 1. Now, if I were to bring that to the left side, we could then have the difference of y of n minus y of n minus 1 equals 2x of n minus 1. And what we're looking for is something that looks like that. So if I were to divide both sides by t, and I'm allowed to do that, t being the time between samples, I now have this, which is what we said we can replace with dy by dt, or a continuous time signal y of t. So that is our approximation. So you can say dy by dt equals 2x of t minus 1 over t. So you notice everything now, instead of being discrete, is continuous. So this is a approximation, but it's what we call our differential equation, because we have a continuous time, first derivative there. Differential equation. So that's our final answer.